Welcome to 6-4B, completing the square. We're going to just use a word problem here. We're going to use this thing called the golden rectangle. It's one of the that can be divided into a square and a second rectangle that is geometrically similar to the original rectangle. The ratio of the length of the longer side to the shorter side of a golden rectangle is called the golden ratio. Alright, so in this part of the problem, we're going to find the ratio of the length of the longer side to the length of the shorter side of a rectangle labeled A, B, C, D. And you can see I built one right here. And you can see that the longer side is AB and the shorter side is BC. In order to do this problem, we're just going to make some assumptions. And our first assumption is that the longer side we'll just call X. That's the length. And in order to solve this, we're just going to say the length of BC is equal to 1. So now we have a ratio of longer side to shorter side. Now you can see that I have divided the rectangle into two parts, a square and another rectangle. And according to the information is that the new rectangle is going to be smaller. And we're going to have to make a ratio for that, the long side to the short side. Alright, so we now have a ratio of EB, which is the longer side of our new rectangle, and the shorter side is BC. And without going into too much detail, EB we're going to say is equal to 1, and BC is equal to x minus 1. Alright, you should have gone over this in geometry, so I just wanted to go over quick how I got over the two ratios, and now I'm going to make them equal to each other. Alright, the reason why I'm able to do this is because they are similar to each other. So that means that ratios are equal to each other, that they have the same. So they're both equal to 1/2 or 5/6 or something like that. Alright, that's not the big part, and this will not be a problem that you will see on an assessment. This is just using this information to complete the square. Alright, this part of the word problem is where we're going to use completing the square. So what we're going to do is we're going to take the ratio that we just made, or the proportion, which is above here, and we're going to use that, of course, to complete the square. It says find the exact value of the golden ratio by setting the two ratios in exercise 4 equal and solving for x. Hint, the golden ratio is a positive value, so there will only be one answer. Alright, you know that when we have two fractions equal to each other, we can use cross multiplication. So we'll do it something real easy here. We're going to take this and cross multiply with this binomial. Remember, this is a monomial being multiplied by a binomial, so we're going to distribute. So we get x, and I'll just go ahead and write it out for those of you. And then I'm going to go ahead and cross multiply the ones. I'm going to simplify by getting rid of the parentheses, so I'm going to distribute. And there you go. I have simplified our ratio. And you notice here, it looks like it's already missing a c, so we're going to have to go find it, if you remember that from the previous video. So I have x squared minus x. I'm going to put a gap there for the reminder of the c. A is equal to, of course, 1, so that means we can go ahead and work on this problem without adjusting for it. B is equal to -1. Alright, so we're going to go ahead and do our formula. Alright, you can see C, which is B over 2, in parentheses raised to the second power. PEMDAS says do everything inside the parentheses, but since it doesn't come out to be an integer, I'm going to leave it as a fraction, and I'm just going to go ahead and square the top and square the bottom. Alright, so now I have my new c, and I'm going to place it into this equation here. Alright, you can see I put that new c here, and remember it's an equation, so we got to keep it balanced, so there we go there. I'm going to go ahead and simplify or combine like terms. And I get 5/4. All right, what we have now is a perfect squared trinomial, and we're going to go ahead and factor that. Here we go, x, and if you remember, we're going to take our original c, which was negative a half inside the parentheses, square it, is equal to 5 over 4. And now we're going to get rid of the square. All right, you can see right now we are getting ready to remove the square, which we did, and we get x minus 1/2. You can see here I have plus or minus to remind us that there's two answers. Since we have a fraction inside a radical, I'm going to go ahead and split it into a numerator and a denominator. You can see the benefit of keeping it as a fraction, because square root of 4 is a perfect square. Alright, I went ahead and square root of the 4, and now I'm going to go ahead and isolate the x, so I'm going to add a half to both sides, which I just did, which gives me x is equal to, and I'm going to put the positive 1/2 in front because it's a real number, plus or minus square root of 5 over 2. And you can notice that the denominators are both the same, so I'm just going to go ahead and put the denominator this way. And if you remember, the original problem says that we don't have a negative, everything here is positive. So our real answer is 1 plus the square root of 5 over 2.